Okay, so as you guys are finishing this up, let me go over this with you. Number one on the left side, okay? So it says asymptotes and holes. Both of those I call AKA, anybody can read this for me? AKA what?
Discontinuity.
Yeah, discontinuity. Okay, so yeah, it's discontinuous. So in mathematics, we call both of those, holes and asymptotes, are both called discontinuities. Okay. Now, you know tonight's homework, you better put that away because you need to pay attention. Asymptotes. Let's talk about two kinds of asymptotes that we have already studied. Horizontal asymptote, it goes like this, right? And then vertical, it goes like this. How do we get the vertical asymptotes? How do we get it? How do we make this line, this vertical, up and down? By the x, right? What the denominator cannot be. Would you guys agree? Okay. And then we also have this line. What does this line represent? The horizontal one. What y can not be. You guys agree with this? Okay. So the y is over here. We're going to focus on vertical asymptotes first. The two kinds of discontinuity that are both created by this guy over here. Okay. So first it says a removable discontinuity if the factor x minus a can be removed. That's why it's called removed, aka it can be canceled. Then that means at the location, so if I take this, set equals to 0 and solve for it, would you agree that x equals to a? So at that location, it's a hole, so i.e. So I'm going to make up an example really quickly, and you should definitely write this in your notes, okay? I'm going to make up an example, and i.e. What do I mean by that? Example. All right. i.e. f of x equals x plus 2 times x minus 3 on the top all over x times x plus 2. Okay? So in this example, we're going to do something quick. I'm going to give things that's already factored. Question number 1. What's the domain restriction? Look at it. What's your domain restriction? Beautiful. X cannot be 0 or negative 2. Can we all agree with that statement? Then I'm going to go and cancel. Anything I can cancel? Right. So guys, based on this, it said, hey, if you can cancel it, there is a hold at where? Hold at x equal to what? Negative 2. Okay? So we cancel x plus 2, the factor x plus 2, but when you take it and you set it equal to 0, it comes out to be x minus 2. So there's a hold at x minus 2 on the graph. So that's one kind of discontinuity. That's a removable one. And it's removable because we can do what? Why is it called removable? Because I can reduce, right? Factor, reduce, cancel, get rid of it altogether. The other kind is called non-removable discontinuity. Okay? That means this is what's really creating the what? The vertical asymptote. So the other one's not removable, which is this guy. You guys see this? So there's so this question has two kind of discontinuity. A removable, which is at x equals to negative 2, and a non-removable, which is the VA, the vertical asymptotes. And this vertical asymptote is at x equals to what? X equal to, what's in the bottom? 0, because x is the only thing that's left in the bottom, right? And if I were to set equal to 0, then it's just simply equal to 0. Any questions on holes and vertical asymptotes? Holes and vertical asymptotes are both called what? Holes and vertical asymptotes are both called what? Discontinuity. Okay? Now on the right side, these are called horizontal asymptotes. And again, so horizontal asymptotes, let's talk about cases. We're just going to compare what? The degrees of the numerator, which is in our equation, is p of x, and to the degrees of the denominator, which is in our equation called q of x. Case number 1. The degree of the numerator, if it's, what's this right here? Greater than the degree of the denominator, then this one has what? No horizontal asymptote. In pre-calculus, you're going to have other kind of asymptote, but we'll save it for next year. So right now, we're only going to study flat lines, okay? Horizontal or not at all. So in pre-calculus, we'll figure something out. So i.e., for this case, let me give you that example. i.e. for case number 1, f of x equals x to the 4th minus 99x plus 1 all over x squared minus or plus 10x minus 5, okay? Let's talk about the degree on the numerator. What's the degree on the numerator? 4. What's the degree on the denominator? 2. Is this a true statement? The degree on the top is bigger than the degree on the bottom? Yeah. So would I have any HA? No. So if you see this and you say, well, the degree on the top is bigger, the degree on the bottom, let me spell it out. What's the degree on the top again? 4. What's the degree on the bottom again? 2. So I would write no what? No horizontal asymptote. Okay, Brandon?
Is the horizontal asymptote y?
Huh? It's y equals. Yep. Yep, you're right. Now, case number 2. The degree of the numerator, if it's less than the degree of the denominator, then immediately your horizontal asymptote equals to what? 0. So i.e., let me make up, I'm just going to switch what I wrote on the top, okay? F of x equals x squared plus 10x minus 5 all over x to the 4th minus 99x plus 1. Again, the degree on the top is what? The degree on the top is 2. You're right. Degree on the top is 2. What's the degree on the bottom? Well, it's 4. So in this case, it says the degree on the top is less than the degree on the bottom. Do you agree with the statement? Therefore, would you have an HA? Yeah. What's your HA?
0.
That's right. But make sure we write y equals to 0 because it's a horizontal line. It's a dashed line that we use. Okay. All right. Now, case number 3 and our last case. Case number 3 says, if the degree on the top is exactly the same as the degree on the bottom, then we simply just have an HA at y equals to A divided by B. Okay? Where A is what? What's A? What's A?
Leading coefficient.
Over. And then B?
Leading coefficient.
Perfect. Let me make up something for you. So what does it mean by leading coefficient? i.e. f of x equals negative 4x squared minus 10 all over 5x squared plus 99x plus 1. Okay, just made that up. What's the degree on the top? 2. What's the degree on the bottom?
2.
Also 2. Would you agree that those are equal?
I would.
Perfect. What's the leading coefficient of the top? Negative 4. What's the leading coefficient of the bottom? 5. Therefore, would you have an HA?
Yes.
Yeah. HA is y equals to what? Negative 4 divided by 5. And that's exactly why. Hold that. So copy it down before we go. We're going to try to finish example 1. Okay. Can you please, Roger, just help me read the instruction to example 1, 2, and 3.
Determine the restrictions on the domain. Do they represent removable or non-removable discontinuities? Is there a horizontal asymptote? So what is it?
Perfect. So 1, 2, and 3. Here we go. Guys, before you can determine the restriction of the domain like last night's homework, what must you do first?
Simplify.
Before you simplify, factor, guys, factor. I'm going to write factor in, okay. So it's the numerator. Can I do anything with the numerator? No, so write 4. Go ahead and factor out the denominator for me. Once you have your factors, can you please consult with your partner, if you have one today, about your factors? If your factors are wrong, and guess what? All things can be wrong. So once you have the factor, compare. And I'm going to call on one of us to give me the final 2 factors for the denominator. If you don't remember how to factor, where should you be tomorrow? Here. I will help you. I will give you practice questions on factoring. Can you talk to your friend now about your factors?
I got X minus 2. Yeah, I did too.
Maddie R., can you give me your 2 factors, please?
I got X plus 5 and X minus 2.
Do you guys agree with those? Perfect. Then we're going to go find the restriction, the domain. What do we do for us to find the restriction domain? Take the entire denominator and set equal to what? 0. All right. So some of you can just do it in your head, and I'm totally okay with that. Some of you have to write it out. That's also okay. So x equals to -5 and x equals to 2. So domain, all real numbers excluding what?
-5 and 2.
That's right. X cannot be -5 and +2. We're going to box that up because that's one of the things they wanted us to find. Then it says, do they represent removable or non-removable? So let's talk about at x equals to -5 and x equals to 2. Were we able to reduce or cancel any one of those? No. So guess what? Both of them are what? Non-removable, because we didn't reduce anything. Okay. Both are non-removable. Both are non-removable. Okay, both are non-removables. Yes, Brandon?
What would make them removable?
Okay, just wait, and then we'll get to the next one, and then I will tell you. Then the next part of the instruction said, do we have an HA? If so, what is it? So to get an HA, guys, we need to talk about the degree on the top. What's the degree on the top? The degree on the top is 0, divided by, what's the degree on the bottom? 2. Now, would we have an HA?
Yeah.
Yes. The top is smaller than the bottom. What is your horizontal asymptote? That's right. HA, we do, and they're going to write y equals to 0. Okay. Now, Brandon said, when will we have a removable? So here's another example. Go ahead before we do anything. What do we do before we even start writing out? Factor. All right, factor it out, you and your team. And then I'm going to call on you guys, just give me the numerator factor and the denominator, all factor out. That's right. Take out 2x. What happened? Go ahead and take out 2x for me. Quantity. What's that? Once you have your factors for both, can you talk to one another, please? James, are you able to factor the top at all? Okay. Talk to your partner, so you can come back to me. Is the numerator factorable? Yeah, okay. Guys, talk to your friends now. If you guys don't have matching factors, they'll definitely be wrong.
You take 2x.
Got it? Alright, hold on. James, give me the top factors.
Well, -4 and 3 are not factors, hon. I need it in the quantity. Just give me the final factor. What are the two factors? Kai and James, talk it out. What are the two factors? X, Kai? What, and James, what is it? X? Someone confirm those for me?
Yeah.
Perfect. The denominator, Lena, what are the factors at the bottom?
2x times x minus 4.
Beautiful. Okay, so guys, before we go and do anything, I'm going to have to find my domain. Take your denominator and do what? Set it to 0. So right away, 2x equals to 0. That means divide both sides by 2. 0 divided by 2 is? 0. Over here, x minus 4 equals to 0. That means x is at 4. So domain, all real numbers, excluding what? 0 and 4. Beautiful. Box it up. Now, let's see if we can reduce. Can someone tell me if there's anything we can cancel? Oh, yeah. So would you agree? If I reduce that, I'm going to end up with an x plus 3 all over 2x? Okay. Out of those two discontinuity, which one do we have a removable? Oh, we do. Removable at what? Removable at x equal to? Which one do we cross out? The minus 4, so x equals to positive 4. Yes or no? Do we have another one that we couldn't reduce? Which one did we not reduce? Which one? X equals to 0, right? Isn't that the one that didn't get crossed out? True or false? So guys, this right here, x minus 4 was able to reduce, be gone, cancel. But the other one that wasn't gone was at x equals to what? Which one did we not? Right, x equal to 0. So this one is a mixture of both. A non-removable, okay? Remember, you have a domain. You're excluding how many values? 2. So they're either removable or they're non-removable. Sometimes they can be a what? A mix. Okay? Now let's talk about HA. Do we have any? To find HA, what do we need to know? Degree. What's the degree on the top? 2. What's the degree on the bottom?
2.
They are equal, right? The degree on the bottom is also? 2. So that means HA or no HA?
Good morning, Oilers. I'm Luke Heina.
And this is Grace Smith.
Here with your morning announcements.
So because the degree are the same, guys, are you going to have an HA or no?
Yes.
Yes. What's the leading coefficient of the top? 1. What's the leading coefficient of the bottom? 2. And guess what? That is done. To be continued next time.